Swayam Prabha. Digital India. Educated India.
Welcome to the course Analysis of Variance and Design of Experiments. So, from this chapter we are going to start a new topic. This is about factorial experiments. So, now the first question comes here: what are these factorial experiments and why they are needed, and what are the different types of definition terminologies which are related to factorial experiments. So, this all I will try to discuss in this lecture, and in fact first I will try to give you a brief idea, and then instead of giving you lots of details, I will try to take here a very simple example, and with that simple example I will try to construct the different types of definition terminologies, and then I will try to make it more general. So, now if you try to see, whenever you are trying to conduct an experiment, either this is complete block design or say incomplete block design, you are trying to consider different factors. If there is one factor, you call it a one way analysis of variance. If there are two factors, then you call it as a two way analysis of variance, and so on. And there are different levels inside each factor. What you try to do? That you try to combine all those effects together, the effects of all the levels together, and you call them as factor A or say factor B. If you remember in your analysis of variance, you have just considered like this. Now, we want to segregate out these effects. For example, if there are two factors, say A and B, right. So, when you are trying to conduct an experiment, what do you expect? What type of factors you can expect? There will be one effect due to factor A, there will be another effect due to factor B, and there will be one more effect that will be due to the interaction of A and B. So, now we are interested in getting an idea about these individual effects. What is the effect of A, what is the effect of B, what is the effect of interaction effect of A and B. So, now how to get it done? This factorial experiments helps in this, and factorial experiment has some advantages also, that if you try to possibly try to achieve the same objective in the randomized block design, possibly I will try to take here an example to show you that you will need two randomized block design. So, two randomized block design mean more plots, more experimental material, but if you try to conduct them through this factorial experiment, you will require less number of plots. So, these are some advantages of factorial experiments. And remember one thing, these factorial experiments are conducted inside a design. So, I try to do here one thing, that in this lecture I will try to take some general simple examples, and through those examples I will try to convince you that how we can define different types of factor and their interaction effects. And one thing what you have to keep in mind, either you want to know the effect of factor A, factor B or interaction effect, what you have to do? You have to do all those things only from the set of available observations. You are not going to means collect more observations, because if you try to do it, that is definitely going to increase the cost. So, now this is the beauty of factorial experiment, that for example, if there are only two factors, say A and B, then we can study about the factor A, factor B, factor AB, just by using 4 observations on different treatment effects. The only thing is this: how are we going to combine those 4 observations in such a way such that from the same 4 observations I can get an idea about the factor A, factor B, as well as interaction effect AB. So, now you can have some sense of feeling that how these factorial experiments are going to be helpful and how are they going to help us in getting more information from the designs of experiments. So, let us begin our lecture and try to see. So, we are going to talk about here 2 raised to the power of n factorial experiment, right. So, well, what is the meaning of 2 raised to the power of n factorial experiment, that I will try to now explain you during the lecture. So, the first question comes, why should we consider this factorial experiment? So, these factorial experiments involve simultaneously more than one factor each at 2 or more levels. This is the case when we are trying to consider the 2 raised to the power of n factorial level. For example, you can see here, you have here the factors and each factor has some level. So, if every factor has 2 levels, we call it here as a 2 to the power of n factorial, and if there are 3 levels, then we call this here as a 3 to the power of n factorial, right. So, yeah, I will try to address all these issues gradually. So, now we have a situation where several factors affect simultaneously the characteristic under study in the setup of a factorial experiment, and the experimenter is interested in the main effects and the interaction effects among different factors, right. So, first we try to consider an example to understand the utility of this factorial experiments, right. Suppose the yield from different plots in an agricultural experiment is to be studied, and we know that this yield is going to depend upon the variety of crop and the type of fertilizer. That we know that sometime he said, okay, if you use this type of seed, then possibly you are going to get a better crop, or if you try to use this type of fertilizer, you are going to get a different type of yield or a better yield, right. So, all those factors are going to affect the yield, and moreover, both the factors are in the control of the experimenter. The experimenter can choose the variety of crop that has to be sown, and the experimenter can decide the type of fertilizer which is to be here used. And there is one more factor here, which is the third factor, which is not in the control of experimenter. So, like a soil fertility, for example, the fertility of the soil is the well, sometimes you try to control it by some chemicals, but we are talking of the natural fertility of the soil, which is given by the nature, right. So, the moral of the story, what I am trying to show you here is that whenever we are trying to conduct an experiment, there are 2 types of say this factors, one which are in the control of the experiment and some other factor which are not in the control of the experimenter, right. So, now in case if you want to compare the different crop varieties, what we can do? We can assign the crop varieties to the different plots and keeping all other factors like as irrigation, fertilizer, etc. fixed, and this is going to be the same for all the plots, right. So, now in case if you try to get the conclusion from such an experiment, then they are going to be valid only for the crops that are grown under the similar condition with respect to the factors like fertilizer, irrigation, etc. that you have considered, right. Now, in case if you want to compare different types of fertilizer or say different quantities or doses of the fertilizer, that you want to give 1 kilogram of fertilizer or 2 kilogram of fertilizer in a given area, then how are the crops going to change, what is the effect and so on. So, if you want to have this type of conclusion, what you can do? you can show a single crop on all the plots and vary the quantity of fertilizer from plot to plot. Right. In some plots you try to give 1 kg, in some plots you try to give 2 kg of fertilizer and so on. So, the conclusions will be valid only if the same varieties of the crop are sown, and this conclusion will become invalid if different varieties of crops are sown. Right. So, now if you try to think about the experimental condition, then it is quite possible that one variety may respond differently than other to a particular type of fertilizer. Right. For example, if you have suppose 2 different types of seeds of say wheat, and they have got a different inherent structure, they are grown in different types of conditions, and if you try to use the particular type of fertilizer, then both the varieties, although they are from the wheat, but they may react differently, they may behave differently. One variety may have a lower yield, whereas the other variety may give you a more yield. Right. So, all these things, the individual effects of the fertilizer, seed variety of seeds, etc., as well as their interaction effects, all these can be studied through the factorial experiments. So, through the factorial experiment, we can study the individual effect of each factor as well as the interaction effect of all these factors. So, now the first question comes here, what are the different types of definition terminologies which are used in the factorial experiment? So, what we try to do here, just in order to explain you, we try to consider here a very simple 2 square factorial experiment, and we try to consider here an example, and we try to develop and understand the theory and notation through this example. Now, what is this 2 square factorial? With this I will try to show you. But before that, if I ask you a simple question, suppose if I take here a variable here, temperature, right? Can you classify it into say this 2 classes? For example, I can say if the temperature is less than 25 degrees centigrades and if it is more than or equal to 25 degrees centigrades. So, can I say that if the temperature is below 25, then I can say ahead that it is low temperature, and if the temperature is more than 25 or equal to 25, I can say here this is high temperature. Well, this 25 I have chosen, but this can be any other number, right? And similarly, if you try to see here, if I try to take here another factor here, say quantity of fertilizer, right. In case if I try to give here 2 kg of fertilizer, say per plot, or if I try to give here 4 kg of fertilizer per plot, right. So, I can say here that this is a small quantity when I try to give 2 kilogram of fertilizer in a plot, and if I try to give 4 kg, then it is a more quantity and so on. So, basically what I am trying to do, whatever is my numerical value, I am trying to divide them into 2 different categories. And similarly, if you wish, you can take here more number of such variables. So, if you try to see here, you are trying to take here 2 variables, one here is temperature and another here is quantity of fertilizer, and each of this variable is at 2 levels. So, we have a setup of 2 square factorial experiment. Now, means at the same time I can explain you, suppose if you try to take here one more variable, say irrigation, and you try to say here if the irrigation is more than 20 centimeters in the plot, then it is high, and it is less than or equal to 20 centimeter, then it is low level. So, now you can see here, now you have added here one more variable here. So, now you have here 3 variables: temperature, quantity of fertilizer and irrigation, and each of them is at 2 level. So, this type of experiment will be called as here 2Q factorial experiments. And now you can see here that we have here these variables. So, variables are going to be indicated by here say capital letters, say capital A, capital B, capital C, and we have here 2 levels for each of the factor, you can see here. So, this 2 is coming actually here. When I try to write down here this 2 or this 2, this is here the levels, and the number of factors, this is going to be here this 2 or this 3, right. So, now I need to develop a symbols, notations, definition, etc., so that I can represent all these things which I have just explained you in a more better way, which anybody can understand, right. Right. So, now, so you have now understand that whenever we are trying to conduct the factorial experiment, we are going to have here factors, and every factors will have some levels. So, this is the general symbol and notation for representing the factors in factorial experiment. We use capital letters like as capital A, capital B, capital C, and the levels of our factor are represented in small letters, and there are some other approaches also. Small letter means say small a, small b, small c, and so on. That is our general symbol. Now, how to do it? For example, if there are 2 levels of the factor A, right, then they are indicated by here A0 and A1. And similarly, if you have here 2 levels of factor B, then they are represented here as say B0 and B1. This is one approach. Some other approaches are also available to represent this these levels. So, the 2 levels of A can also be represented by the 0 and 1. So, this 0 is corresponding to A0 and 1 is corresponding to A1. So, you can see here this 0 which is written in the subscript, this is coming over here, and this 1 which is written in the subscript of A1, this is coming here. So, similarly, for the factors B, we can represent the 2 levels by 0 by this here B0 and B1, as well as this 0 can come over here, and I can represent here as a 0, and this 1 of B1 will come here, and I can represent it here as a 1. So, this 0 and 1 will represent the 2 levels of factor B, right. So, now if I try to take here a very simple example, suppose if I try to take here one factor here as a temperature, and I try to take here low temperature, and then I try to take here high temperature, and this is up to you that how do you define what is the lower temperature and what is the higher temperature. For example, just for the sake of understanding, I can say when I am trying to use any temperature less than or equal to 25 degrees centigrades, that will be classified as low temperature, and whenever I am trying to use any temperature which is greater than say 25 degrees centigrades, then it is going to be considered as a higher temperature, right. And suppose I try to take here one more variable here, say quantity of fertilizer. Suppose I try to choose here 2 kg of fertilizer, which will be called as lower value, low level, and similarly I can have here say 4 kg of fertilizer, which will be called as higher value. Now, if you try to see, you conduct the experiment. So, what are you going to do? You will fix the temperature which is say less than 25, say, or in the category of low temperature, and you will try to use 2 kilogram of fertilizer, and whatever temperature whatever the value of yield at this temperature and with this fertilizer you are going to get, that is going to be represented here by this, right. You can write down here low temperature LT and low fertilizer LF. Means you are going to conduct the experiment, you are going to give the lower quantity of fertilizer, that is 2 kilogram of fertilizer, and you are going to maintain the temperature less than or equal to 25 degrees centigrade, and then you are trying to conduct the experiment and you are trying to get the outcome, say yield from the plot, which is indicated here y. Similarly, you can conduct the experiment with say high temperature of say HT, and you can use the low quantity of fertilizer, that is 2 kilogram. So, this is here LF, and then you will try to obtain here a value of y, that is the outcome. And similarly, you can consider here say lower temperature and say here higher value of fertilizer, and then you will conduct the experiment and you obtain here the y. And similarly, if you try to take here they say high temperature and say high for fertilizer, and then you obtain here the value of y. So you will have here another value of y. So now you can see here you have considered low temperature and low fertilizer, high temperature, low fertilizer, low temperature, higher fertilizer, and higher temperature, higher fertilizer. So, these are the 4 treatment combination that you have considered. And now, whatever are the outcomes of these combinations, we can indicate them by writing those treatment combination inside the bracket, like as here this. So, now I have shown you here, but these are for a particular type of example, but we need to make it more general, so that a general factorial experiment can be expressed in the proper way. So, now you can see here these 4 treatment combinations we can write down here as a A0, B0, A0, B1, A1, B0, A1, B1, right. So, you can see here that A0 is corresponding like as here, this is here A0, this is here A1, this is over here B0, and this is here B1, right. So, you have here A0, B0, you have here A1, B0, you have here A0, B1, and then you have here A1, B1, right. So, alternatively these values can be also expressed here as a 0, 0. So, this 0, 0 means this 0 in the subscript that is coming here. Similarly, you can write down here A0, B1 here as a 0, 1, and A1, B0 you can write down here as a 1 and 0, and A1, B1 can be written here as a 1, 1. So, that is going to indicate the 2 levels. So, this 1 and 0, they are going to indicate the 2 levels of the these 2 factors, and actually that can also be written in other way, which is here like as I can write down here A0, B0 like as here I, right. So, and this A0, B1 here as a B, A1, B0 as a here A, and A1, B1 as a here AB. One simple way out to understand or to remember that how are we going to obtain this thing is that you can consider as if you are trying to write down here say A raised power of 0 and B raised power of 0. So, this will come out to be here something like here 1. So, 1 is being indicated by here identity say I, right. And then simply if you try to consider here this A0, B1. So, it can be written here A raised power of 0 and B raised power of here 1. So, this will become here A raised power of 0 is 1 and B raised power of 1 is B, which is here 1 into B is here B. And similarly, A1 B0 can be written as A raised power of here 1 and B raised power of here 0, which is here A, and similarly this A1 B1 can be written as A raised to the power of here 1 and B raised to the power of here 1, which is here A into B, right. So, this is how we try to manage these symbols. So, I denotes that here both the treatments are at the lower level, means 0 0. Well, means that is our general understanding that by 0 we are trying to indicate the lower level, and with 1 you are trying to indicate the upper level, right. Okay. So, now the second notation is that you want to write down here this these value. For example, you can see here you have written the outcome in the form of this brackets. So, when we are trying to write down here A B, that means this is the mean of all the observation which receive the treatment combination A B, and if there is only one observation, then this A B, when it is written inside the parenthesis, then it is going to increase the value, that is the yield from that plot or the outcome from that plot or the outcome from that experimental unit, right. And when you are trying to repeat this experiment, for example, the experiment which I have shown you here with the 2 levels of temperature and 2 levels of fertilizer, that can be repeated, and then you are trying to give this treatment combination, for example, this A B in different plots or A B in different experimental units, right. Then this is going to indicate the mean. Very important point to remember is that the factorial experiments are conducted in a design of experiment. For example, the factorial experiment is conducted as an RBD or inside an randomized block design. So, that is what you have to keep in mind. So, now I can just formalize all this definition. So, if there are 2 levels of A, they can be denoted by A0 and A1. If there are 2 levels of B, they can be denoted by B0 and B1. If there are here 2 levels of C, they can be represented by here C0 and C1, etc., and so on. So, you can see here these levels are indicated by the lowercase alphabets, and these factors, they are indicated by here uppercase alphabets. So, other notation what we have learnt here, for A0 and A1 we can use here 0 and 1, for B0 and B1 we can use here 0 and 1, for C0 and C1 we can use here 0 and 1, right. So, this is how we are going to proceed, and in this case when you are trying to take here 3 factors, say A, B and C, and each of the factor is at 2 level, the total number of treatment combination will be here 8. What? A0, B0, C0, A0, B0, C1, A0, B1, C0, A0, B1, C1, A1, B0, C0, A1, B0, C1, A1, B1, C0 and A1, B1, C1. Now, you understand how you are going to conduct the experiment by looking at this treatment combinations, right. Well, at this moment, means if you are learning the factorial experiment for the first time, do not get confused that it is a difficult thing. It is a very simple thing, and there is a very systematic approach to find out these treatment combinations and all other things, right. At this moment, I am simply picking up the expression directly, so I am informing you. Okay, now we come to an example. We try to consider an example, and through this example, I will try to develop different types of definitions. So, now you can see here, for example, if I try to consider here a 2 square factorial experiment, that means there are 2 factors each at level 2. That means there are 4 possible treatment combinations, based on which we have here 4 values of the observation. So, now the question is, using those 4 observations, we have to find the effect of factor A, effect of factor B, as well as the interaction effect, right. So, for example, in case if you are trying to consider here 2 factors, say here say the irrigation, and suppose here is nitrogen, and suppose if irrigation has 2 levels I0 and I1, and suppose for a while that nitrogen also has 2 levels N0 and N1. So, in this case we are going to consider here a 2 square factorial experiment. But on the other hand, if suppose irrigation has 2 levels and nitrogen has 3 levels, then what will happen? We have to conduct the experiment accordingly, right. So, based on that, we will also have a situation where I can say that all the factors have got the same number of levels, or all the factors they have got different number of levels. So, whenever we have the factors where each of the factor has got the same number of levels, that is called as symmetrical factorial experiment, or otherwise that is called as asymmetrical factorial experiment, right. For example, if I try to consider here a simple example. Suppose we want to compare these 2 levels of irrigation I0, I1 and 3 levels of nitrogen N0, N1 and N2. Now, suppose you do not want to use the factorial experiment. So, what we will do, that we will try to consider here 2 randomized block design, and then we will try to write down the different levels of nitrogen in different blocks, such that none of the level is appearing once or more than once in every row and every column. So, you can see here I have written N0, N1, N2, N2, N0, N1, N1, N2, N0 and so on, right. And so, I try to write down here 2 times. Now, I want to compare the different levels of irrigation. So, what I can do, that in this RBD I try to give here the level of irrigation as I0 to all the plots, and similarly in the second RBD I try to give the level of irrigation as I1 to all the plots. So, you can see here how many plots are needed, 9 here and 9 here. So, in order to make such a comparison, you need here 18 number of plots. And how are you going to conclude? When you are trying to compare the observation from the RBD number 1, then you can only have an idea about the difference among the nitrogen levels, because irrigation level is the constant. And similarly, if you try to consider here this RBD, where the irrigation level is fixed at I1. So, here also you can get only an idea about the different levels of nitrogens, means how the different levels of nitrogen are going to impact the crop when the irrigation level is fixed as I0 in the case 1 and as I1 in the case 2. Now, in case if you try to compare both these RBDs, then you will get also an idea about the difference among the levels of irrigation, that what is the effect of the different levels of irrigation on the crop or on the outcome, right. So, now in order to understand different types of such terminology, that how are we going to do it, let us try to consider here a 2 square factorial experiment, and we consider here only 2 factors, irrigation and nitrogen, which are indicated by here capital I and capital N, and both of them are at 2 levels. So, irrigation has 2 levels, which is indicated by here I0, I1, and nitrogen here has 2 levels, which are indicated by here N0 and N1. So, you can understand here that this I is something like here factor A, and is something like here factor B, and this I0 is something like A0, and I1 is something like here A1, and N0 is something like B0, and N1 is something like B1, right. Well, you can ask me why I have not indicated the 2 levels of irrigation by here I1, but the problem is this: with the type of font what I have used, it will look like this. So, That is why I have taken it to be a capital calculator, so that you can see it clearly. That is the only reason. Right. So, now if you try to look at this structure, which is a sort of table, and through this table I will try to explain you several concepts. You have to go slowly and you have to understand that how I am going to do it. So, you can see here I am trying to take here two factors, irrigation and here nitrogen, and the two levels of irrigations are indicated by here I0 and here I1, and the two levels of nitrogen are indicated by here N0 and N1. Now, we try to conduct an experiment and we try to use here the level I0 N0 in this plot and I0 N1 in this plot, I1 N0 in this plot and I1 N1 in this plot, and then we try to obtain here the outcome, and that outcome is going to be here indicated by, say here like as within parenthesis I can write down here A0 B0 or equivalently 1, means I, that is indicated as, I mean like this is actually here 1, and similarly I0 N1, that is going to be indicated by here A1 B0. So, A1 is coming from here and B0 is coming from here, right, and that is equivalently say here A, and similarly I1 N0, that is going to be indicated by here within parenthesis A0 B1, which is equivalent to here B, and similarly here this I1 N1 is going to be indicated by here A1 B1 inside the parenthesis to indicate the yield, which is equivalent to here AB, right. Now, we have here 4 observations. Now, I try to use this observation and try to draw different type of conclusions. How? That is what you have to understand. In case if you try to consider here this and this, that is I0 N0 and I0 N1, and try to find out their arithmetic mean, right, that is equivalent to writing down here this 1 and here A as 1 plus A upon 2. Now, if you try to see how this structure is looking like, you can see here that this I0 is common to both the terms. So, do not you think that it looks like as if this is the average effect of nitrogen for the fixed irrigation level I0. You are trying to take here N0 and N1 divided by 2, and where the I0 level is fixed. The same thing if you try to see here, this can be expressed as here 1 plus A upon 2. And similarly, if you try to see here in the second column here, I am trying to take here this I1 N0 plus I1 N1 and then trying to find out the average arithmetic mean. So, you can see here this is I1 N0 plus I1 N1 divided by 2. So, you can see here this I1 is common in both the factors. So, this is actually N0 plus N1 divided by 2. So, do not you think that it looks like as if this is the average effect of the different levels of nitrogen for given irrigation level I1, and the same thing can be written here using here this B plus AB divided by 2, which is here like this. Okay. And now, if you try to see here, if I try to take the arithmetic mean of here this I0 N0, I0 N1 and I1 N0, I1 N1, then this is going to be the sum of all the factors I0 N0, I0 N1, I1 N0, I1 N1. Just try to find out their arithmetic mean divided by here 4. So, to confirm it, right. So, if you try to consider here all the factors here, say here 1, A, B, AB, and try to find out their arithmetic mean, this will be looking like as here, say 1 plus A plus B plus AB divided by 4, which is the general mean effect, right. So, now we come to the last column and try to see here how are we going to proceed. Now, I try to compare here the two groups mean, like as here this and here this. And what I try to do here, I try to find out the average effect of n for the given irrigation level I0 minus average effect of n for irrigation level I1. Right, you can see here, these are the two comments which I have used here. Now, if you try to see here what it is trying to give you here, the effect of nitrogen is going to be the same in both this average effect, and then you are trying to see the effect of this irrigation. So, can you call this difference as main effect due to irrigation? And in case if you try to write it down, means either you try to write it down in terms of I0, I1, N0, N1, or you can directly now use here 1 AB, AB. You can write down here this B plus AB minus this here 1 plus A divided by 2, like this. So, this is going to give you here the main effect of B. Right. So, you can see here just by using here the 4 observations on 1 A, B, A, B, you have found that how you can find out here the general mean effect as well as the main effect of B. Now, I try to extend, means you can understand here. Now, I am going to move in this direction, right, but I do not have here the table. Table space here. So, instead of going into this direction further, I am trying to now move to another slide. You can see here all these things, they are the same. This whatever I have written here, this is all here the same as earlier. Now, I try to consider here, now I can remove it so that you can see it clearly. Now, I try to consider here the difference. I try to subtract I0 N1 minus I0 N0, like as here. So, now if you try to see here that in this case I0, I0 they are the same. So, do not you think that it appears like this is the effect of nitrogen for the irrigation level of I0, and similarly the same thing can be written here by subtracting here A and 1, like as here, like this one. And the same thing I can do here for I1 N1 and I1 N0. So, I try to take here I1 N1 minus I1 N0, and in this case you can see here this I1 is the same in both the factors. So, this is essentially N1 minus N0 in some sense. So, do not you think that it is appearing like as if this difference is going to give us an idea about the effect of nitrogen for irrigation level I1? And the same thing I can write down using the notation, say B and AB here as say AB minus B, right. Now, I try to compare these two effects, these two differences what we have obtained. Now, in case if you try to subtract both these differences and just divide it by 2, it will appear as if you are trying to divide it by 2 and you are trying to take the average, that similarly you are trying to divide here by 2. Well, I must accept here that I have taken this very crude example to explain you, so that at the end when I am trying to express the general terminology, you should be able to understand it, but at that moment I will not have this type of approach available by which I can explain you. So, that is why I have taken here a very simple example to explain you that how these things are coming, and rest after this I will simply ask you to think yourself, and based on that this logic you can extend it further. So, from that point of view you simply try to consider it, and ultimately you will see that all these factors 2, 4 etc. I will explain you how are you going to obtain them in a scientific way. So, if you try to see here, if I try to compare the effect of this nitrogen at different levels of irrigation, so I can consider here this effect of nitrogen at irrigation level I1 minus the effect of nitrogen for irrigation level I0 like as here, and divided by 2. So, if you try to see what it is trying to give you, this is the effect of nitrogen for different levels of irrigation level. And if you try to rewrite the same thing, I can write down here this AB minus B by 2 minus A minus 1 by 2 from here. Now, if you try to see, this is the effect of different levels of nitrogen and different levels of irrigation. Now, I ask you one thing, can you call it as this is the interaction effect between A and B? Yes, if you try to see, you are simply trying to consider here both different levels of irrigation and different levels of nitrogen. So, this is how we try to estimate or find out the interaction effect of A and B, and this general mean effect that remains the same as earlier, no issue. Okay, now, if you try to see, I started from this table and I had moved in the horizontal direction. Now, I try to do the same exercise in the vertical direction, in this direction. As I do not have the space here to show all these things in a single table, otherwise things will not be clear. So, that is why I have partitioned it, right. So, now you can see that I am going to in this direction here in the next slide, and this part is same here, you can see here this part is the same as earlier. So, now you can recall that earlier we had taken these 4 values and we had moved in this direction. Now, we are going in the vertical direction. So, now you can see here I am trying to do the similar exercise what I have done in the last 2 slides. I try to consider here I0 and 0 and I1 and 0, and I try to find out their arithmetic mean here like this. You can see here in this term N0 and N0 is the common between both the terms, and this is essentially I0 plus I1 divided by 2. So, can I consider it as this is the average effect of irrigation for a given nitrogen level N0, and the same thing if you try to define in terms of here 1 and B, I can say here this is only the arithmetic mean of 1 and B, that is 1 plus B divided by 2. And similarly, if you try to consider here this I0 and 1 and I1 and 1, I try to find out their arithmetic mean. So, you can see here this N1 and N1 is the common between both. So, this is essentially the average effect of irrigation for the given nitrogen level N1, and this can also be expressed here as say A plus AB divided by 2, which is the arithmetic mean of A and AB, right. So, now if you try to see here, in case if you try to compare these 2 means, this and here this, what do you observe here? This and this, if you try to take their difference. So, this will be here average effect of irrigation at nitrogen level N1 from here minus average effect of irrigation at nitrogen level N0 from here, and this can be written here as say also in terms of 1 A B A B, that this A plus A B divided by 2 minus 1 plus B divided by 2. And if you try to consider the structure of this statement, this is trying to say the average effect of irrigation at N1 level minus average effect of irrigation at N0 level. So, now what do you see here? The average effect of irrigation is can be considered as common between both. So, this is essentially giving you the main effect of here nitrogen, right. So, this is how we can compute it. So, the main effect of A is going to be computed by A plus AB divided by 2 minus 1 plus B divided by 2. And once again, if you try to see, the general mean effect will remain the same, there is no issue, right. Now, I try to do the same exercise once again. So, if you try to see here that earlier you have, in the earlier slide you have obtained this I0 and 0 plus I1 and 0, both of them their arithmetic mean like is here. So, this is the same thing. Now, I try to consider here, because now I have here a space. So, I have clubbed it together. Now, if you try to consider here the difference between them. So, I try to consider difference between I1 and 0 and I0 and 0 like as here. You can see here in both the cases N0 and 0 is the common. So, one can consider here it that as if this is the effect of irrigation for the given nitrogen level at N0 level, right. And in case if you try to express this same thing in terms of 1 and B, so I can write down here this here as a B minus 1. Okay. So, now if you try to consider here the other part, you can see here you try to take the difference between I1 N1 and I0 N1 like as here. So, now if you can see here this N1 N1 is the common, and it appears like you are trying to consider I1 minus I0. So, do not you think that I can consider it as effect of irrigation for nitrogen at N1 level? And the same thing I can indicate in terms of A and AB as a AB minus A. Now, you try to consider here both these differences, this and here this, and try to take the difference and divide it by 2, just you have done in the case of earlier slide. If you try to see here, I try to take here the effect of irrigation for N0 level and effect of irrigation for N1 level, and I try to find out here this difference, effect of irrigation for irrigation level N1 and irrigation level N0, and I try to divide here by 2. Yeah, means there is a reason why I am trying to divide here by 2. Well, so and the same thing if you try to write down here in terms of 1 A B A B, you can write down here A B minus A divided by 2 minus B minus 1 divided by 2, right, from here and from here, right. And what is this going to you? If you try to see, this is effect of irrigation as well as effect of nitrogen. So, irrigation is at 2 level I0 I1, nitrogen is at 2 level N0 N1, and now somehow you are getting here a quantity, this one, which is indicating the joint effect of the 2 levels of irrigation and the 2 levels of nitrogen. So, can you consider it as interaction effect of A and B? And now, if you try to see here, this interaction effect which you have obtained here and the same interaction effect that you obtained earlier here, you can see they are the same, right, because the interaction effect of AB is the same as the interaction effect of BA. So, this is now you have obtained here, you obtain here the main effect of this irrigation, main effect of nitrogen and the interaction effect of irrigation and nitrogen. Okay, so now we come to an end to this lecture, and you can see here that was very interesting lecture in the sense that we considered the cutoff of 2 square factorial experiment. We have just 4 values, remember, and just by considering the different types of combination of 4 values 1, A, B and AB, we have found here 4 quantities: the effect of A, effect of B, the interaction effect of AB, as well as the general mean effect. That was straightforward. So, one thing what you have to understand, that when we are trying to find out these effects A, B, AB, how are we going to combine these values? That is very interesting and very important. It has a statistical reasoning, which I am going to discuss in the forthcoming lectures. And this, the way I have combined one A, B, AB, it is not arbitrary. And my promise to you is that you know how we have combined it. The only thing is possibly you never thought in that direction. So, now I have given you here some idea that how one can find the main effects of the factor as well as their interaction effect using these treatment combinations or the observations on these treatment combinations. But here it was a very simple setup, only 2 factors, 2 levels. So, I can show you here all these calculations, but definitely you can imagine that if I have here 3 factors each at 2 level or different level, or 3 factor 3 levels, etc., this type of analysis will be very difficult to explain it on the slides. But once you understand this thing, now if I ask you, can you consider about 2Q factorial experiment, which has factor A, factor B, factor C, their interaction effect AB, BC, AC and ABC. They can also be thought that there are going to be 8 such treatment combinations. You are going to obtain the observations and then you have to combine them in a particular way, so that you can obtain all these main effects and interaction effects. So, now you try to look into these slides, look into this lecture, try to revise it, try to understand it, that how using those treatment combination I am trying to infer about the main effect and the interaction effects. Means how these 4 values are giving us all these values that we wanted to know. And this is actually based on certain logic, that how are we going to look at these values. So, you try to revise it and I will see you in the next lecture with more details, more discussion. Till then, goodbye.